Hello viewers, in today's class we are going to discuss one important problem from limits, right? And here we have to find the right hand limit and the left hand limit of this given function when x approaches to 0, right? So here the function is given as x times e raised to greatest integer of x plus mod of x minus 2 divided by greatest integer of x plus mod of x, right? So here in this lecture we'll find the right hand limit and the left hand limit of this function when x approaches to 0, and we'll see whether the limit of this function it exists at x is equal to 0 or not, right? So let us start and let us first find out the right hand limit. So here the notation for the right hand limit is given by limit x tends to 0 positive, right? So here we'll put a positive sign over 0, and here we have f of x, right? So if we take x is equal to 0, then for finding out the right hand limit we are approaching from x is equal to 0 towards x is equal to 0 from the right of x is equal to 0, right? And when we find the left hand limit, then we are approaching from the left of x is equal to 0 towards x equal to 0, right? So for the left hand limit, we'll take a point in the neighborhood of x is equal to 0, which is 0 minus h, right? And when we find the right hand limit, we'll take a point in the right neighborhood of x is equal to 0, and we'll call this point as 0 plus h, right? So now we'll take x is equal to 0 plus h, right? Where h is a very small quantity, it is infinitesimally very small, and moreover h is positive, right? And h lies between 0 and 1, right? So we'll take x is equal to 0 plus h while finding out the right hand limit. So x is simply h, and when x tends to 0, then h tends to 0, right? So now we can express this right hand limit in terms of h. So we have limit h tends to 0, and here for f of x we can replace x by h, right? So we have f of h. So now we have limit h tends to 0, and f of h can be obtained by replacing x by h in this function, right? So we have h, then we have e raised to greatest integer of h plus mod of x. Here we have h, and then we have minus 2 divided by greatest integer of h plus mod of h, right? So now we see that here we have the greatest integer of h, right? And we have mod of h. So the greatest integer of h is 0. Why? Because see, h lies between 0 and 1, or in other words we can say that h is infinitesimally very small quantity, right? So h is very close to 0, right? And the greatest integer of h is 0, right? And mod of h can be written as simply h. So now this limit can be written as limit h tends to 0. Here we have h, then we have e raised to 0, right? So greatest integer of h is 0. So here we have plus, and for mod of h we have simply h, and here we have minus 2 divided by 0 plus h, right? So now let us simplify it further. So we have limit h tends to 0. Here we have h, and this is e raised to h minus 2 divided by h, right? Now this h and this h get cancelled, so we are left with limit h tends to 0, and we have simply e raised to h minus 2, right? Now we can substitute h is equal to 0 here, so we have e raised to 0 minus 2, and e raised to 0 is 1, so we have 1 minus 2, that is minus 1, right? So the right hand limit of this function f of x when x approaches to 0 is equal to minus 1, right? So we can easily draw a conclusion that right hand limit is finite and it exists. Now let us find out the left hand limit. So the notation for left hand limit is limit x tends to 0 minus, here we'll put a negative sign over 0, right? And here we have f of x, right? So while calculating the left hand limit, what we will do, we'll take here 0 minus h, right? So x can be taken as 0 minus h, and again here x is equal to minus h, because 0 minus h is minus h, right? And when x tends to 0, then obviously h tends to 0, right? And moreover h is positive quantity and it is very close to 0, and we can say that it lies between 0 and 1. So now we can express the left hand limit in terms of h, right? So we have limit x tends to 0 minus can be replaced by h tends to 0, right? And we have f of minus h because x is now minus h. So we can now write limit h tends to 0, and f of minus h can be written from this expression by replacing x by minus h. So we have minus h here, and then we can write e raised to greatest integer of minus h. Then here we have mod of minus h, and this is minus 2 divided by greatest integer of minus h plus mod of minus h, right? Now we need to find out this limit. So now see, here we need to find out the greatest integer of negative h. Now see, h lies between 0 and 1, right? So minus h, it should lie between minus 1 and 0, right? So when h lies between 0 and 1, then minus h lies between minus 1 and 0. So the greatest integer of minus h should be equal to minus 1, right? And mod of minus h can be simply written as mod of h, that is equal to h, right? So now this limit is the limit h tends to 0. Here we have minus h, and e raised to greatest integer of minus h is minus 1, and mod of minus h is simply h, right? So here we have plus h and minus 2 divided by here we have minus 1 for this greatest integer of minus h, and here we have plus h, right? So now we can write this limit as a limit h tends to 0, and here we have minus h, and see, if we take h is equal to 0 in this expression, we have minus 1 plus 0 minus 2, and this is minus 1 plus 0, right? So this is negative. We can take this negative sign outside the limit notation. We have limit h tends to 0, this is h, and here we have e raised to minus 1 minus 2 divided by minus 1, right? Now this negative sign and this negative sign get cancelled, and this is a constant, right? So we can take it outside the limit notation sign. So we have e raised to minus 1 minus 2 multiplied limit h tends to 0, and here we have h. So now we can see that this limit is equal to 0, right? So we have e raised to minus 1 minus 2 times 0, right? So this is equal to 0 because this limit is equal to 0. So 0 times e raised to minus 1 minus 2 is equal to 0. So we can see that the left hand limit, it is also finite, and it exists and it is equal to 0, right? So viewers, in this problem we have seen that although the right hand limit and the left hand limit are both finite and they exist, but they are not equal, right? So minus 1 is not equal to 0. So we can claim that the limit of this function when x approaches to 0, it does not exist, right? So it does not exist because for the existence of a limit of a function at some particular point, the right hand limit and the left hand limit both should be finite, and they should exist and equal to each other, right? But in this case the right hand limit and the left hand limit are not equal to each other, although they exist and finite. So the limit of this function when x tends to 0, it does not exist.